So I promised that we are going to do massive revisions today, and we are going to start from the first question in mathematics tutorial sheet 1, sets. I'll be very quick so that we don't waste much time. Okay, so today we are doing what we are calling as MSM 1 revision. All right, so we'll start from the first question in the tutorial sheet. The first question in the tutorial sheet. Okay, there are 20 people in that group for mathematics. There's only 10. All right, so we start. The first question was saying the universal set you are given the universal set they gave you the universal set of this particular set. They said this was -2, then this was -1, this was 0, then this was 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 7. And then they said X is a set of even numbers in U. Okay, so even numbers in U is set X. What are the even numbers in U? So we know that even numbers, -2 is an even number. You need to take note of that. 0 is an even number. Okay, +2 is an even number. 4 is an even number. 6 is an even number. Okay, all numbers divisible by 2, including 0. Y is a set of all prime numbers. So what are prime numbers? Numbers that are divisible by 1 and itself, right? Numbers divisible by 1 and itself. So 2 is divisible by itself. So in this case, then prime numbers, we are going to have 2. Prime numbers start from 2. Okay, then we are going to have 3, and then 5, 6, and then 6 is not a prime number. Okay, so 6 must be out. So this is going to be 5, and then a 7. So this was the set that they gave you. And then what else? And then we're told, say, and Z was this set. They said this was -2, then this was 3, then 5, then 6. Okay, so the first operation we're given is to find X union Y. B were to find X intersection, that is X intersection Y. Okay, so the third one was X intersection Y / Z. And then the last one, which is G, we're taught to find cardinality of X union Y. So we do the solution. I think we have, I won't be doing this much. Anyway, it's okay like this. So we do our solution. We start with X union Y. What set is this? We are uniting x and y, so we are uniting this set to this set. What is x union y? What is x union y? What is that set?
-2.
-2.
0.
0.
2. 2, 3.
-2, 0, 2. 3, 4.
4, 4, 5, 6, 7.
5, 6, and 7.
5, 6, 7.
Okay, so this is the answer for the first question. We go to B. Okay, so if you have a question, just unmute yourself and talk to me, because yeah. So we have done x union y. We find x intersection y complement. So I always tell you, work out what is in the brackets. So this is just the same one as x intersection y. So let's find x intersection y first. Where is x and y intersecting? We have 2, we have 2. So this is going to be this set. It's all intersection at that point, right? Okay.
Yes.
Then we say this now complement. So we are getting everything except what 2, right?
Yes.
Yes. So this is going to be everything except 2. So you just get everything in the union except 2. So this is going to be -2, -1. Complement simply means get everything that is going to remain in the union set if you remove 2. So you go to the union set, just remove 2. Get everything that remains. Then you have 1. You're going to have 3, 4,
4,
5,
5,
6, and
6, 7.
7. All right. We go to C. Okay, see if it comes in the test they give you. These operations are very simple. You just have to know what you're doing. So this is just the same as x intersection. Now this operation here, we have always talked about it. It is the same as x minus z, right?
Yes.
So all the members in y which are not in z. So let's operate that. So y minus z. All the members in y not in z. What set are we getting? So 2 is also 2 is in y, but it is not in z. So 2. 3 is in y, but it is also in z. 5 is in y, it is also in z. 7 is not. So this is the set, right? Then we have been taught that we intersect x intersection this set. What are we getting? Only 2. 2 is in x. 2 is also in this guy. It is here. But 7 is not in 2. So we won't include it. So in this case, x intersection y minus z is this particular set. Cardinality. Cardinality is when you count everything. X union y, we find the cardinality. Where is x union y? It is this set. So we have 1, 2, 3, 4, 5, 6, 7, 8. So cardinality of this particular set is simply 8. Okay, so that is how we solve the first question. That is how we solve the first question. Right. Let's go to the second question. We see how we are going to solve it. The second question, okay, the second question is saying let x, they've given you 0 here, then 10 here. Okay, let it be the universal set, and then we have been told that A is this set 1, 4, B is 2, 8, C is 3, 6. Then we say let them be the subsets of X. Find each of the following. So the first operation is a B, okay, like that. The second operation is A intersection B. Okay, C, they're saying we have A intersection B. D, we have A intersection B slash C. Then E, we have X slash A. Okay, union A slash B. Okay. So we can do our operation. We get first of all the universal, which is going to be our X. And then we can get the, okay, so we have our 0. Then we can put our 10 here. We can name this one X. Okay, smallest number 1. We can set 2 here, 3 here, 4 here. What else do we have from 4? Smallest number 6, 6, and then we can have 8. Have I put all the numbers there? Yes. So first one is A included. So in A, set A, we have 1 included here. At 1, we have this bracket, it is included. We take it to 4, included, you shade like that. B, we have an open circle at 2. So you are going to open the circle at 2. And then you are also going to open the circle at 8. And then we are going to go at 3. We are going to shade the circle at 3. And then we are going to open the circle at 6. We can do our operation. The first one is B complement. B complement, this was our A, this was our B, C. B complement, since there's an open circle here, so we are going to shade the circle and then we take it this side. That becomes our B complement. We also come this side, we shade the circle, we take this side, and that becomes our B complement. So B complement is going to be this set from 0. 0 was part of the universal, it was included, so we are going to say 0 comma, and then 2 is part of B complement, so you put your 2, and then you say union of, and then you are going to say you come here, since 8 was part of the B complement, 8 is part of B complement, and then it goes all the way to 10. 10 was part of the universal, so this is going to be our B complement. We go to B. B, we have been told that it's A intersection B. So where is A and B intersecting? Okay, so they are intersecting at this particular point. This is the region where these guys are intersecting. So if you notice, 2 is part of set A, but there is an open circle in set B. Henceforth, 2 won't be part of the intersection. So you are going to put your 2 with with these brackets, and then 4 is part of set A because there is a shaded circle, and it is also inside set B, so it is going to be included. Okay, that is the intersection. And then we go to C. C, we have been taught that it's a set A intersection and then B slash C. So this is just the same as I've been announcing. This is just the same as B intersection C complement. Okay, so B intersection C complement. So first of all, let's work out C complement. So you go where there is C. Okay, C is here, so let's find the complement of C. Okay, so C complement, you go there was here at 3, it is shaded, so there's going to be an open circle there which is going to go this direction, and then that becomes our C complement. Even on the other side, okay, because this side it was open, so it will be shaded, and then you take it this side, and that becomes our C complement. So C complement, that becomes our C complement. Then where is B intersecting with the C complement? Where is B intersecting with C complement? B is intersecting with C complement at this point. Okay, at this point. Sorry. It is B intersecting with C complement and not B complement intersecting with C complement. So I will go where there is my set B is this guy here. So where they intersect with C complement, they are intersecting here. Okay, this is where they are intersecting. Okay, that region. Even this side, where are they intersecting? They are intersecting at this point. Okay, so we have seen where C complement is intersecting with B complement, right? But then we have been told that it must also intersect with A complement. So where is B intersecting with C complement, then intersecting with the set A? So now you include set A. So set A is ending here. So meaning this C complement which is surpassing set A, we won't include it because set A is ending at this point. So this one, we won't include it. We are only going to include this particular C complement because it is in set A. Where are they meeting? They are meeting at this particular point. Okay, you see it. It is going in set A. It is also going in set A. So this is where C complement, B, set B and set A are going to meet. Where are they meeting from? At 2 and 3. Right? Yes, we have seen what is happening. Okay, these things are not hard. Just see what is happening. Okay, if I was to shade it, it is this region here. Okay, it is this region here. Okay, this region. This is the region where these guys are meeting, right? Yes, this whole region here. Okay, from this point to this point, from this point, we have seen that B, C complement and A, set A are all included in the intersection. Where are they meeting? Let's first of all check. 2 was part of set A, but it wasn't part of set B, but it is part of C complement. So since it is intersection, we are supposed to show that 2 must be in all the sets. But since it is not in all the sets, we are going to open the circle because there is an open circle at B. Okay, comma. Then 3 is in set A, it is in set B, and it is but it is not in C complement because there was an open circle here. Henceforth, we are going to put our 3 here also. That is where the set is intersecting. Okay, that is where the set is intersecting. Okay. That is where the set is intersecting. Okay, with practice, you are going to understand this. We go to the last one, where they were saying that we have x slash A, and then the union of A slash B. This is just the same as x intersection A complement the union of A intersection B complement. Okay, so first of all, we have A complement, it is here. We haven't found A complement. So A complement is this set. It is going to be an open circle here going this side. Okay, this is going to be your A complement. Okay, so but here there was a cross circle. Here there was a cross circle. So this is going to be, let me use another color. Okay, someone wants to join. The moment you are logged out, log in. Okay? The moment you are logged out, log in. Don't start commenting in the group, making noise for your friends. Don't start telling us, say I've been logged out. Won't do anything because it's the network. So, okay, so there's no one who is being logged out. The network is very much stable, and we thank God for that. So here there was a close, it was shaded here. No wonder I've opened the circle. Let me also open the circle here. I'll take it this side, I'll open the circle. That is going to be my A complement. But where is it intersecting with x at this point? That is why it is intersecting with x. Have you seen? At this point, okay? Yes, yes. That is why it is intersecting with x. Okay, let's also check where is A intersecting with B complement. B complement is this set here. Okay, so where is set A intersecting with B complement? Set A is only intersecting with B complement at this point. Okay, this is B complement. It is intersecting with set A at this point. At this point. Okay, this side there is nothing because set A is ending here. Okay, at this point. So this is where these guys are intersecting. This is what B complement is intersecting with set A. Now they're saying we unite everything, right? We unite everything. So x intersecting A complement. Where is x intersecting with A complement? This side x is intersecting with A complement at this point, right? Okay, and then this side. Okay, so what I'm going to do is this. X intersection A complement is this set. Where is it? X intersects with A complement. It is, this is x. So A complement is here. This is A complement. So it is going to come from 0 included because that was part of the universal. But 1 is not part of A complement. So we are going to open the circle at 1. Union. Then we go this side. Where is A complement? I'm solving for this. I haven't started for this. So A complement is this set. It is starting from 4, an open circle at 4 because there is an open circle there, and then it goes all the way to 10 was part of the universal. Then we solve this guy now. Have you seen how I'm simplifying them? We solve A intersection B complement. Where is A intersecting with B complement? B complement is this set. A is this set. They are only intersecting at 1 and 2, at only these numbers. Okay, A is ending here. B, the other B complement is this side. Where are they intersecting? There's a line here, not nowhere. So this set is 2. 2 is in set A and it is also in B complement. So I'll put a 2 there. Sorry, I'll put a 1 here. Then 2 is in B in set A and it is also in B complement. So I'll say a 2 there. Then I combine the set. If I combine the set, I'm going to have something like, because there is a 1 here, there is a 1 here. Okay? So this is going to be a set which is going to come from all the way from 0, comma. Now since we have a 1 here which is part of the of this particular set, okay, so we are going to put a 1 here. Okay, we are going to put a 1 here. Okay, no, okay, no, I want to do maths. Let me just do my maths. Why should I put 1 when there is a 2 here? Let me just put a 2 here and include it, because this, we have 1 here included, we have 1 not included. So since 1 wasn't included in this particular set, include it because of this set. So no wonder why I've put 2, because I know that this is an interval, there is already 1 in between. Then I'll say the union of 4, 10 included. That is the whole set combined. That is how you are supposed to solve the second question. If you have a question, just unmute yourself and talk to me. I have solved that one. I'm revising with you because I want you to do better. I want you to do best in your exams. So question 3, you are going to solve it. I think I solved it in a video, but I've given you question 3 as your work. Write it somewhere as question 3. I want you to see, because this is interval notation still. I don't want to do interval notations, but I think I solved it in a video where there's a video that I showed you on interval notations. I named it as proving De Morgan's law and interval notations. I think you've seen it. I solved this question. I don't want to solve so much of these questions. They are simple, but I want you to solve it for me. And a lot of you, I gave you as work this question, you solved it. A lot of you got it right, but I just want you to redo it for the sake of revision. Question 4. Are you able to see question 4? Question 4, they are saying for each of the following sets, state whether it is finity or infinity, and in each case justify your answer. So the first one, you are given A is equal to, and then they give you a set of 0, then they say 1, and then they say intersection R. B, they said B is equal to this set X is such that X is a member of, and then they say this is going to be R, and then they say X power 2 must be less than 4, and then C is equal to 0, then 1, And then, so all those of you that are supposed to pay, please pay us. Pay us so that we won't be blacking out when it's time to teach. Already I'm receiving warnings from Airtel. Now me, I want to teach. Airtel is interested in money. Me, I'm interested in making my students pass. Who is selfish? I made a post in the group. I said, give me, I want people to react. I want 40 reactions. And I'm going to solve questions on that. The reactions are more than what I commanded. So I'm sure you ask questions. Why do you tell people to react in the groups? All my groups are closed. All the groups that I run are closed. So that's the only way you can talk to me. If I say this, react to this, I want to see how many people are interested. I don't like opening my groups because people share unnecessary things. Others ask unnecessary things. You are logged out, you log in immediately. Solution. How do you prove this is finity, infinity, whatever? Okay. I'll be very quick. The first one. Who is this one who wants to join this class? Felicitas Mwanza. Some of you, I don't even know you. Some of you, I don't even know you. You've never joined my class. So this is 0,1 intersection there. So this is the real line. They're saying all real numbers, this symbol. So intersect this guy with all real numbers. You will still get that guy. You will still get this set. A finite set is a set with countable members. Infinite set is a set with uncountable members. So this set is a finite set because it only has two members, you can count them. You go to B. X is such that if you have never enjoyed maths before, this is the time to enjoy maths. Maths is very simple. This is the only time you can enjoy. So they are saying x is a member of all real numbers, but the conditions are that x to the power 2 must be less than 4. So you solve. Okay, so this is just the same as square root of that, square root of that. You are going to have x. X is going to be less than -2, x less than 2. What am I doing? Okay. This is just the same as x is equal to -2, x is equal to 2, but this is okay because both -2 and 2 are less than 4, right? Correct. Now you have a set of -2 and 2. Is this finity or infinity? A girl to unmute themselves and tell me. I don't need to beg a girl to tell me. Just unmute yourself and tell us. Agape, tell me, is this a finite set or infinite set?
It's finity.
Thank you so much. Thank you so much. I appreciate. Finity. I appreciate. We got to see. All right. We got to see. So what are we going to do? What are we going to do? How do we solve this one? Zero intersection that. How do we solve this one? How do we solve this one? This is this thing here that you see. This is an interval, right? So if you do this, if you want, you can do this. You put your 0 here, you can put your 2 here, you put your 1. And then you can, yeah. What is 3 divided by 4? It will be 0 point something. So let's just say 0 point something. I don't know what number. Here. So here there's a cross circle. Here there's an open circle. Here there's a cross circle at that. And then what is 3 over 2? It will be 1 point something. So let's have 1 point, let's say x here. And then there's an open circle. No need of this side. So notice the intersection of this set. For the first one, it's going to all the way to 1. Okay, so this guy is going all the way to 1 like that. No need of even doing this. You even know it's going to be a finite set. Okay. Wait a minute. We need to check first. Alright, the second one, it's coming from this point to this point. So these guys are supposed to be intersecting at this particular point. So they're intersecting at the C is a set which is going to start from all the way from that 0 point x number to 1. Now this is an interval. Okay, from 0 0.1, from 0 0.4, I don't know if it's 0 point something, up to 1. Are you able to count the numbers? Because this is going to be 0 0.0000000, 0 0.01, 0 0.02, 0 0.03, 0 0.04, until you get to 1. Are you able to count? Are you able to count? Are you able to count it? If you can count it, you know the answer. We go to D. X is such that it's a member of all real numbers. But we have been given this equation and the constraint is that x is odd. So you will get this number equal to 4. Then you find the square root, you find the square root. You are going to get 2, you are going to get negative 2. Are these odd numbers? I want a girl to tell me, Helen, tell me, are these odd numbers? Do we need to beg Helen to unmute herself? Who is there? I don't know. Pauline. Tell us. Are those odd numbers? Are those odd numbers? Okay. Chabu Chibwe. Are those odd numbers?
Maybe just to help. No, they're not odd numbers, they're even numbers.
Oh, those are even numbers. Good. Thank you. So these are even numbers, meaning this set is an empty set because the conditions are not meeting. We don't have any odd number. You see how much is easy? Uh, Angela Mukubesa, you see how much is easy? Angela, can you get me? Have you seen how much is easy? Maths is hard, maths is easy. Hmm? You learned from the notes from the first video which I sent that an empty set is a finite set. Okay. Where are we? I'm even feeling tired now. Someone is saying network in the group. Network is misbehaving. I don't want anyone to go in the group and start posting things. Don't go in the group to post things. Just join.
Actually, sana network.
Just join. You catch us. Just join. Network here, comment campus. Which question am I doing again? At which of the sets listed below are equal? Okay, this one I'll solve. I needed to solve this one. Which of the sets are equal? These two more questions that seem to be. I don't know. People may get confused, so I'll solve them. Then, okay, I needed to solve this because I'll get a lot of questions. I'll get a lot of questions. Sir, this question. Mm-mm. Okay. And then D. D. This was the set. We want to see which ones are equal amongst these. Let's test them, can we? We'll start with the first one. Let's test A. So A, let me test it. I have 1, and then I have 2, I have 3. First, I have a cross circle here. cross circle here. Teveachupa nokutesta. Sorry, this is an open circle here. What? Yeah. And then there's an open circle also here. It's the same two. There's an open circle. This is the first one. But for the second one, there's an open circle here. Are you sure these guys are intersecting somewhere? Are they intersecting anywhere? Which girl can tell me? Me, I love girls. Okay, I love girls to tell me what I'm teaching. Okay. Who is going to tell me? Banda. Tell me, are they intersecting anywhere, these guys? Really, Banda. Are they intersecting anywhere?
They are not intersecting.
Okay. Alright, thank you. So this is an empty set. We go to B. One.
So basa
Uh-huh.
success intersects ya pili yawa abiri.
You will see what I mean. You will see what I mean. Cross circle here. 2. And then cross circle here. Cross circle here. Where are they intersecting? Charles, where are they intersecting? At 2.
As 2.
Okay, let's go to C.
Hapa muna.
Let's go to C. These are just sets. Have you seen? These are just sets. No need of an interval notation. You can only put an interval notation when you need to be when you need to be taken to China. That's when you only need an interval notation. Okay. We'll tell Sister Agape to give you some tracks. So what is the answer here? Sister Agape, tell us what is the intersection there?
They are equal.
Tell us intersection number she.
You mean for B?
For C.
Oh, for C, let me look at the question again.
What you have this set? Where are they intersecting with this set?
It's 2.
All right. If you mentioned another answer, class was going to end immediately. So what do you want to tell me? Okay, shh. Go and get me water. Then you tell them not to close the door. Okay? Good girl. Alright. So my daughter just came to give me good news. So this is going to be 3. Do I need to draw anything here? Okay. Thank you. Please give me water also. Okay. Imwe, monen, check. You have this set, aye. 1. Omuteti ibe mu 1 already 1 wife nyako. But between 1 and 2, between 1 and 3, apa pari 2 pak, sorry, apa. Munife 1, ndio vya chibe mpasa tumishita understand. Na 3, in set, common set. But muri 2. So where are they intersecting these guys? Someone to just tell me the answer. No need to draw this. Where are they intersecting? Unmute yourself, you tell me. Where are they intersecting? Not to close the door. Can someone tell me where they're intersecting?
The intersection at 3.
People are studying. Which ones are the same? So it's only B and C which are the same. Okay, so I'm going to give you right again, right. Shama interval notations mokular solve. I want you to solve those things. I've done it. I labored so much to teach this. So question 5. Answer question 5. A and B. Those things, answer them. They're very simple. I solved this question. It was very simple. I said I would give them. And then I also, now in 10 minutes, I want you to do question 6. In 10 minutes, I want you to do question 6. Question 6 only, in 10 minutes. Okay? Don't leave. If you leave in 10 minutes, I want you to answer question 6. In 10 minutes, I want you to answer question 6. Please answer question 6. Don't leave. Answer question 6. Open your tutorial sheet.
So both A and B.
Hmm?
Both A and B.
No. Leave B for me. B, you won't solve anything. Just answer question 6A. I want you to see what you're going to get. I want to see if people are familiar with this. So you can only answer that for me. Just answer that for me in 10 minutes time.
kushedda fekamu.
Okay. Have we solved the questions? Have we solved the questions? Let's see what you solved. Okay, so we are on questions. They were saying, okay, let me check. Okay, I can see there's someone who has solved. Another person to solve. Okay. So question 6, they're saying A and B are disjoint sets. So disjoint sets are sets which have nothing in common. So if those guys are disjoint sets, you are going to have this set. Okay, let's say this is going to be your X. Okay, this is going to be your set Y. These are these sets are. There is nothing in common in between them. They are not attached, right? Then they say, then simplify X complement union Y complement. How do you simplify this? If these two are distances, they have nothing in common. So this can also be written as you can use De Morgan's law from here first. Let's use De Morgan's law. So x complement union y complement. You know from De Morgan's law that this is just the same as x. Sorry. If you don't know De Morgan's law, you'll be lost here. But this is very simple. It is the same as x intersection y complement. Then you get what is inside. X intersection y. Accordingly to what we have been told, there is no intersection here. Have you seen? These two, they can't intersect because they are not attached. And intersection means like this. But these two are like this. So what is the answer here? X intersection y. It is the empty set. So this is just the same as x complement union y complement equal to the empty set. What is complement of the empty set? You are just going to get everything in the union set. In other words, what I'm telling you is that complement of the unions of the empty set is the universal set. So that is how you simplify this particular question. Should we tell people that we are back in the group? So some people don't listen. We tell them to solve, they go offline. Okay, so let's solve B. B, they are saying P intersection P, yeah. How do you simplify this? This is just the same. I remember telling you that this is P complement intersection. Then complement exposed to P is going to be P complement. Complement exposed to the union set becomes the intersection set. Complement exposed to Q becomes Q complement. Let's factorize. P and P is common. P complement. Intersection and intersection is common. What is going to remain? What is going to remain inside is going to be what? What is going to remain inside? Let me see what we are having here. Okay, so we have P complement intersection that to. Okay, so what is going to remain is Q complement. Yeah. Okay, so this is just the final answer anyway. Have you seen the way I've made it simple? I've used your mathematics language, factorization. You have seen the way I'm factorizing them. You have seen the way I'm factorizing them. You will see. These things, you just fear them. Pairs, so that we make them simple for you. second part, let me show you. The second part, you have P intersection. It's been long since I solved this, but I'm able to remember the rules. You will see. Okay, so the first thing, check, is there anything that you can work out anywhere? Okay, so we have P intersection Q union P intersection Q complement. Okay, so we know that this is already in the simplified form, because this is just the same what P P slash Q. P slash Q is the same as P intersection Q complement. So it is already in its simplified form. Let's factorize. What is common? P and P is common. Intersection and intersection is common. Then we have Q here, but this side we have Q complement. So Q is going to remain, and then union of Q complement. Okay, Q complement. When you reach here, what are you going to do? Whenever you have a union of a complement of a set by itself, you are going to get the universal. For example, you have set Q, and then they're saying unite it with the Q complement. What are you going to get? Q is a set, then you unite it with everything that is outside that Q. So if Q is our main set, then we say get everything that is outside Q, which is now Q complement. We get everything outside Q. Everything outside the Q is going to be the universal set. Are you getting what I'm saying? Anyone who is behind there? Is there anyone who is behind? Just be quick. Tell us, say, I'm behind.
Yes, sir.
Look what I'm
I'm
saying.
behind.
Look what I'm saying. This is what I'm saying. I need to be watching from Jiberenjo by now. All right. So this is what I'm saying. Every set has got the union set. Right? Every set has got the union set. So the universal set. Every set has the universal set, which comprises everything. So let's say the universal set is 1, 2, 3, 4, 5, 6. Then Q is a set 1, 2, 3. Then we say, since Q is the set, have you seen that whatever is in Q is also in the universal set? The same girl who whatever, unmute yourself and talk to me. Have you seen that what is in Q is also in the universal set?
Yes, sir.
Then we say Q complement. What are we saying? We are saying now get everything which is outside Q. So when you get everything that is going to be outside set Q, what are you going to remain with? Tell me the numbers.
4, 5, and 6.
No. No. get everything outside set Q. Imojua. Mrefu njambo kurashire vintu ifi.
That's what everything said.
Get
That is 4, 5, and 6.
so 4, 5, and 6. Okay. Yes. 4, 5, and what? And 6. These, where are they? These numbers, where are they? Where are they? In which set? Which set? Where did you get these numbers from? That lady.
From the universal set.
Exactly. No wonder I was saying you remain with the universal. Clear? Have you understood what I'm saying?
Yes.
So this is what I was saying. When you have a set uniting by complement of a set, is you remain with the universal. So no wonder why here it's P intersection the universal set, and P intersecting the universal set is going to give us P itself, set P itself. It's all about thinking, and it's very simple. See, complement exposed to P complement becomes the set. Complement exposed to the intersection set becomes the union set. Complement exposed to Q complement becomes Q as a set. We go to D. D is saying these are not tuitions. This is being a data point now. I'm spoon feeding my students. Is this correct?
That's why we are here.
I'm spoon feeding you people. So this is a complement. So what you do, work out what is here first. Put everything in this language. So now, if I put it in this language, this is same as P intersection Q complement. Complement exposed to P becomes P complement. Complement exposed to the intersection becomes the union set. Complement exposed to Q becomes Q complement. The union of C exposed to P complement becomes P complement. This one exposed to this becomes the union set. That exposed to Q complement becomes the set. I think I mentioned that along for some time. Complement exposed to Q complement becomes the set. This is common, this is common. This is common, this is common. We have Q complement, we have only Q here, so we are going to remain with Q complement. Then we maintain the union, then Q complement. When you have set C uniting with Q, are we making sense? Sorry. I'm wondering now why it's not making sense. Why did I even put the intersection here? So someone could not control me, say, sir, you made a mistake.
Exposed to the complements.
So this exposed to this becomes that. So no wonder why here we put the intersection. Now, when you look, you have Q complement intersection Q. Can someone just tell us what this is? Imagine now what a set Q. Ero bakwe bati vula ifiri panse fya Q uvishite intersect nefiri mukati fya Q. Ure kwa tenshi ukwati fya maseti yavi. Students think. What are you getting here? I was finding it that you find you from the way I know it should give you something empty, because these two should not have anything in common. So P complement union the empty set is going to give you P complement. Chap. Set operations are very simple, guys. They are very simple. See how many people are reacting to that message in the group. People are blank. They don't know set operations. 54. Things that are very simple. Are you understanding? The rest on that part, I want you to solve them, because I want to test you. I want to see your knowledge, if you're going to make me proud or you're going to make me sad. Okay, so I'll test your knowledge on that. What's next? No. Please, this other part you do yourself. We've done a lot. When are you writing your tests?
Next week.
Cancelled. We end here. We'll continue from here. All right.